Today we're going to talk about acceleration and the graphs of motion. So we'll understand what it is, we'll do calculations using the formula, and we will go through each of the graphs that you need to understand. So first of all, acceleration, we've talked about it before, is the change in velocity over time. So when you're doing change in velocity divided by the time it takes, you will have two velocities, a final and an initial. You will subtract final minus initial. So the formula would look like this. A equals Vf minus Vi divided by time. Remember from the previous lesson, if you have two times, you can subtract the two times as well. Tf minus Ti. So this is the rule that we will use. The unit is meters per second squared. Sometimes it's minus 2. They cancel this slash, which makes it minus 2. So meters per second squared is the unit. So it's meters per second per second. Here's an example. A car starts from rest and reaches a velocity of 42 in 14 seconds. What is the acceleration? There's a key here. It says rest. You need to understand that rest means the Vi, in this case, because I started from rest, is 0. So now I know my Vi, I have my final velocity, which is my Vf, and I have my time, which is my T. So if I want to find the acceleration, I have my Vf, my Vi, and my T. I can substitute it into the formula. 42 minus 0 divided by 14, which is 3 meters per second squared. Formula, numbers, answer. This is how you will do this in your exam. If there's an object that's slowing down, you will get a minus, you'll get a negative value. That's fine. That is sometimes known as deceleration. Here is an example. A car slows down uniformly from 8 meters per second to 2 meters per second in 2 seconds. Find the deceleration. So we need to find the A in this case again. Final speed is 2 because I slowed down to 2. I started at 8. Vi is 8. Time is 2. So if I put the numbers into this way, I'll have 2 minus 8 divided by 2 minus 3 meters per second, or deceleration of 3 meters per second. So if the velocity and acceleration of an object has the same direction, it will be speeding up. So if I have a car and it's pointing to the right, the speed is to the right and the acceleration is to the right, it is speeding up. Likewise, if it's going to the left, it will be speeding up. However, if they're in opposite directions, it will be slowing down. Speed is currently going to the right, but if I press the brake, my acceleration is negative, going to the left, just like the previous example we did. So he will slow down. And the opposite is true if he was going left. The acceleration will be in the opposite direction, he will be slowing down. And it's another way for you to determine what's going on. If you look at this, there's a big gap here, smaller gap, smaller, smaller, and looks like he stopped. So in this case, he has negative acceleration because his velocity, he's pointing to the right, but he's slowing down. So his acceleration is to the left. Look at the left one here. He is going to the left, and his acceleration is also to the left because he is getting a bigger distance. He is speeding up to the left. As you remember from before, right is positive and left is negative. Likewise, up is positive and down is negative. So keep that in mind. So here's an example. This car is going to the left. What of these dot diagrams will describe this motion? You will see that he's going to the left and getting faster. So that means these arrows A and B are wrong. It must be either C or D. It is getting faster, so I'll have more space towards the end. So you can see that this one has more space, whereas D is slowing down, so that's wrong. The best answer in this case would have to be C. Another example here is we have the dots now. Arrow is pointing to the right and it looks like he is slowing down. So which one's the best answer? You can see that B is the best answer here. Okay, so can an object have acceleration and constant speed? Actually, yes, it can. What can happen is it can change direction. I can be going to the left. I can be turning around a roundabout. I can be going this way. My speed can be the same if this is my car and I am going on a road and it's turning to the left. My speed will be the same, but I'm changing direction. So if I am changing direction, there is an acceleration, because acceleration is a vector. A vector has size and direction. So if it's speeding up and have a negative acceleration, based on the previous things that we did, yes it can. Of course it's possible, because what will happen is that it will be going to the left, accelerating to the left, speeding up to the left. That takes us on to the graphs of motion. So you need to know about all the different types of graphs. This is the main thing, velocity time graphs. This could be an object speeding up, constant speed, slowing down. You also need to know the distance graphs and the acceleration graphs. So let's go through them. So speeding up, we've already agreed that it looks like this. Constant speed looks like this, and the slowing down looks like this. This is the velocity time graph. Here is my displacement time and my acceleration time. If I am speeding up, I am covering more distance, more as I go, and I will get a little curve like this. It will be a curved line. If I'm speeding up, my acceleration is positive, so it will be a positive number, and it will be a constant acceleration. These three are related. Constant speed is like this, which means I have a constant speed. I am covering a same amount of distance every second, so it will look like this. That means my acceleration is 0. I have no acceleration at all. So you can see a little pattern forming here. If this is like this will be like this. If this is like this will be like this. Finally, slowing down. This is happening like this, and it will be the opposite of this. As I'm slowing down, it will be starting off fast and getting smaller and smaller and smaller as we go. And if this is like this will be a negative acceleration, so it will be on the negative side. So these are the 9 graphs that you should know about when it comes to this topic. I have them there as well. So here's an example. You should be able to know which one has a faster acceleration. We can understand that B has a bigger slope, so B has more acceleration. You can calculate the rise over run for both, and you will realize that B has a bigger number. Similarly, for deceleration, B again has a bigger slope, so this will be decelerating more. If you did need to calculate the rise over run to calculate the acceleration on a velocity time graph, this will tell me the acceleration. If it was a distance time graph, it would tell you the speed, the velocity. But right now we have a velocity time graph, so that means I can find the idea. In this case, let's see what the acceleration is. Rise over run. So let's figure out what the slope will be. So let's choose 2 points. I'm going to pick 10 because that's nice and easy. And I'm going to pick 2 as well. You can also pick 0, but I've decided to pick 2 just to show you how it works. So if I pick 10 and I pick this 2, and this is going to be 1, this is going to be 5. Rise over run. So 10 minus 2 divided by 5 minus 1. That will be 2 meters per second. You'll get the exact same thing if I did 10 minus 0 and I did 5 minus 0. 10 divided by 5 would have been 2. And it's a positive number, so it's positive 2 meters per second. And we can say that he is speeding up because it is positive. A same idea when it comes to deceleration. You pick yourself 2 points and then you can calculate it. We did do a bit of acceleration and rise of run in the previous lesson, but here we go. There is my first point, and here is my second point. I will see where we are with them. I will do my rise, which is going to be now 80 over 40, over run, which is going to be 6 over 2, 6 minus 2, sorry, I should say. 80 minus 40 divided by 6 minus 2. And you will get 40 over 4. And then you will get 10 meters per second squared. Very nice. It's slowing down because it is going in the negative side. So we have 10 meters per second and he is slowing down.